My name is Rob Hindman, and I'm a program manager on the Windows Server team. I have a lot of areas that I focus on, but primarily I focus on cluster. I've got two areas that are very relevant here. One is cluster OS rolling upgrade, and the other one is in-place upgrade for Windows Server. So what I'll do, I'll be talking fairly broadly today about the approach that we use here. So basically, we want to guide you to be successful when it comes to upgrading your Azure Stack HCI appliances. Now we think about, so let's talk about terminology really briefly. You can see that there's two topologies in this diagram. On the left-hand side, we have the disaggregated, also known as converged topology. This is where we have two separate clusters, one for storage and one for compute. On the right-hand side, you can see there's a hyper-converged infrastructure topology. It's basically where the two clusters on the left side have been compressed, just pushed into one single layer. And this is we call this hyper-converged infrastructure. So basically, you've got storage and compute, in other words, storage and virtualization, all running together on the same cluster. Feedback from customers is that they really like this approach because it's it's easier to manage, right? It's fewer machines, and it's basically higher density and lower cost. So a lot of our customers are really enjoying the Azure Stack HCI solutions. And it's important to understand also that Azure Stack HCI, it's based on a storage technology that we call Storage Spaces Direct, or S2D. So sometimes you'll hear me just use those two terms interchangeably. But let's talk about how we upgrade these things. So and actually, we'll talk a little bit about Storage Spaces Direct. I work a lot with the SQL Server team, but also we work with Hyper-V too. And there's a huge advantage when it comes to this storage topology. The advantage being that it's all Ethernet based, and when you can leverage RDMA technology, then you can really move a lot of data and between machines, and so you can keep sort of redundant copies of your data around, and it's a great idea. It's a great thing. It really reduces cost. We developed S2D in order to make sure that we had a good competitive story with the VMware vSAN and Nutanix. And we're very happy with the Storage Spaces Direct. We think it's proving to be a very good approach. And as far as we know, we have a lot of customers who are very happy with this. So let's talk a little bit about another great thing about Storage Spaces Direct is that it's 100% software. So it will run everywhere. It runs fastest on premises, of course. But it'll run virtual, and so it's a very interesting solution, and in the fact because it runs everywhere, and we're seeing a lot of customers look at that. Okay, so let's talk about upgrade. So before, I'm assuming that everyone is going to be familiar with the Azure Stack HCI, and if you're not, then you should go and look at the Azure Stack HCI documentation. On the front page, there's some fantastic videos and diagrams, and there's just a great there's some really good material here on the Azure Stack itself. So it's really good. Just a quick note that before you upgrade a system, you should always back up your data. So, all right, and then next, I want to also show you the Storage Spaces Direct documentation. So the Storage Spaces Direct documentation is here, and it's really quite thorough. You can find a lot of information on these within this collection of documents. And again, there's some excellent videos here that explain Storage Spaces Direct and explain the replication and resiliency settings for Storage Spaces Direct. So it's pretty good. I encourage you to familiarize yourself with that if you're not already familiar. Now, importantly, inside this documentation, inside the Storage Spaces Direct documentation, we have the guide that actually talks about how you upgrade a Storage Spaces Direct 2016 cluster to Storage Spaces Direct 2019 cluster. And so we have the upgrade steps right here. And we wrote this because based on feedback, we think between 40 and 50% of our customers are very interested in an in-place upgrade. So we've put that there. So please have a look at that. It's in the deployment section. All right. It's very important to read the prerequisites in the deployment section, or in that guide, in the upgrade guide, because mainly there's some constraints. Basically, we want these systems fully patched before they're upgraded. And also, the other thing that's important for us is we want you to note that there are a couple of features that aren't going to be present when you upgrade a system from 2016 to 2019. Most of our customers don't need these two features. They don't need the map log bypass, and they don't need compaction, but some of our customers do need them. Now, if you read through the documentation, you'll see there's this decision flow chart that looks like this. Essentially, you have to start with a Windows Server 2016 Storage Spaces Direct cluster. The first step is to check if you need the map log bypass and compaction features. If you do need them, then you can't really upgrade the cluster. If you need those features, you're going to need to build a fresh cluster and copy data over. But if you don't need those features, then you can successfully upgrade your Windows Server 2016 cluster to 2019. Then you just have two decisions you have to make. First of all, do you want to keep the VMs running? In other words, do you want to attempt a zero downtime upgrade of the cluster? And then the next question is, do you want to do an in-place upgrade, or do you want to do a clean OS install of each node in the cluster? So basically, based on your decisions, you'll wind up in one of these four paths. And today, I believe Bill will be talking about how you perform an in-place upgrade while the VMs are running. So Bill will talk about path A. That's my understanding.
My name is Bill Webster at Florida Polytechnic University. And I'm going to talk about the process that we went through in journey with our Storage Spaces Direct cluster. So in this particular case, we were building out a new DR data center, and we wanted a solution that was cost-effective and could easily be scaled out. So given my prior interest in Storage Spaces Direct and my experience with DataON and the level of support they provide, we decided to deploy one of DataON's 2-node HCI clusters, and we did that back in June of 2018. Then, of course, after Ignite back in the fall, I was excited to get some of that new functionality and features that were coming with 2019. So I started conversations with the folks at DataON to see about two things, both upgrading that cluster to Windows Server 2019 and also expanding that out so that we would have more capacity. So as you can see on the timeline here, we started that with the upgrade in April of this year, and then in June we added the 3rd node and additional storage. So in the next few slides, I'm going to talk through the process that I went through for both of those steps. As Rob mentioned before, there's some really great documentation that Microsoft has out there for upgrading a Storage Spaces Direct cluster. These are on his decision tree. These are the 4 buckets that you could end up in, where you're doing an in-place upgrade with the VMs running, or clean OS install, or likewise with the VM shutdown. As I looked over those and looked at our environment, I decided that this top option, the in-place upgrade, was the best choice for us, both in terms of speed to get that going and also what I felt like the risk factors. So on this slide, this is an overview of what our infrastructure looked like when we began. So we had the 2 server nodes that were running Windows 2016, and we had those connected up to 40 gig Mellanox switch for the storage and replication traffic. And then on the blue lines, those are the networking for our VMs. And then on top of those 2 nodes, we had the storage pool that was built across drives in both nodes. And in the storage pool, we created 2 volumes so we could have one kind of active on each node. And since it's just a 2-node cluster, we created those as 2-way mirrors. And then, of course, we had the VMs running on those, running in the compute space on those nodes on top of that storage. So over here on the right, these are kind of a summary of the steps that I went through, and I'm going to jump down through those pretty quick. As I go through those, when there's cases where I had like PowerShell commands that I ran, I'm going to include those at the bottom of the slides just as a reference so you can see how simple the process is. So the very first thing that I had to do to the cluster was apply the OS updates, make sure that I was running the latest version of Windows Server 2016 with cluster-aware updating. That was really pretty simple. Anybody who's familiar with running that or with a storage spaces direct cluster already, that's pretty easy. So once I had all of the updates on, this is kind of optional, but I like to explicitly migrate everything off that I can. So I opened up Failover Cluster Manager, did a live migration to move all of the VMs from node 2 off to node 1, and then I also moved the storage owner over to, for volume 2, over to node 1. So there's a command listed here at the bottom when you're dealing with set switches, so that's switch embedded teaming. The documentation notes that you need to disable live migration checks, so I just ran that command. It's pretty easy. Then I ran my suspend cluster node, so any roles that might have still been on node 2 would have been migrated off at that point. And again, you can do that in Cluster Manager or simple PowerShell command down there at the bottom. So the next step I did was I placed that server in storage maintenance, and then it was all ready to start hacking away on it. So I mounted up the Windows Server 2019 ISO, ran my setup.exe, and did a upgrade install. Chose the option to keep all of my settings and files. So, I mean, it kept all of the network settings, all of the Windows features, kept the join to the cluster, join to the domain, so I didn't have to worry about any of that. Couple reboots later, you know, after I had Windows Server on there, or Windows Server 2019, then I did my driver updates, and then I applied the latest Windows Server updates, which for me, I can't stress how important that is. I actually ran into a minor issue where I was seeing high memory utilization, and it just so happened that that was fixed within a few weeks in the following Windows Server 2019 quality update. So as long as you today are going through this process and you make sure to get your system updated, I mean, that's at least one problem I know of that you wouldn't run into. So once the updates are all done, then basically you want to back out the other changes you made. So remove that storage or that node from storage maintenance and wait for the storage repair jobs to finish. So down here, I've got the command to list those out, the get storage job. And for me, with our workload, I want to say that took about 45 minutes or so for all of the data that had been changed on node 1 to get synced over to Node 2 while I was doing the upgrade. And then once that's all done, you just migrate all those VMs and roles back and repeat that same process on Node 1. And then at that point, where you've got both server nodes upgraded to Windows 2019, I redistributed the volumes and the virtual machines, and then there's just a few steps to run and make sure you get all of that additional functionality. So upgrade the cluster functional level and upgrade the storage pool. And then I also ran this command down here, the third one that I have listed at the bottom. And what that let me do was change my default settings for the mirror volume type, where when I created new volumes, it would create those. Oh no, I think I'm getting ahead of myself. I'll come back to that. So once you're done with that, then just run the test cluster, and like you would when you're setting up a whole new cluster, you just want to run that and make sure that you don't get any new warnings or errors that you need to address. So then the next step in that process, once I had those both upgraded to Windows 2019, I reached out to DataON about getting another node, and we actually purchased additional drives to expand out the capacity in our existing nodes, and then we added a third node that would give us more compute capacity and better resilience. So, and the final step once I had that in place was to migrate from our two-way mirror volumes to three-way mirror. So just to recap, this is where I started with after I had everything upgraded to Windows Server 2019. So I've got my two nodes with the two-way mirror volumes and the VMs running on top of those. And the very first thing we did was we popped in the additional drives that we purchased, and those were automatically claimed by Storage Spaces Direct and added into the storage pool, so I didn't have to do anything special to get those going. And then we added in the third node. So once we got that all racked and cabled up, there was a little bit of prep work to configure networking on the server and join it to the domain. And then from that point, I just ran the test cluster, again, like you would if you were setting up a new cluster, and specified all three nodes so that I could run those checks and look at storage, networking, OS patch levels, all of that good stuff. And when that came back and confirmed that I was in a good place, I went ahead and did the add cluster node command. And at that point, I had then switched that over to a three-node cluster. And here's where I was mentioning earlier that I ran this command to change my mirror volume so that future volumes would be created as a three-way mirror instead of two by default. And so once I had that done, then as you can see here, I created a third volume as a three-way mirror, so that was across all nodes, which gave me much better resiliency when it comes to server and disk failures. And once I had volume 3 created, I migrated all of the VMs that were on volume 2 over to volume 3. And for that, I just went into Failover Cluster Manager and did a storage migration. So that was migrating those two new storage while the VMs were up and running, so there was no downtime incurred there either. And once I was done, had all the VMs moved over, then I removed volume 2 and recreated that as a three-way mirror. So at that point, it was just a matter of shuffling things around a bit, and basically, as I said, recreated volume 2 as a three-way mirror, moved the VMs from volume 1 over to volume 2, then deleted volume 1, recreated it as a three-way mirror, and then I redistributed my VMs where I had a little bit better balance. So my final end state then was that I had my three nodes with three volumes in the storage pool that were each three-way mirrors and VMs running on all of those. And through both of these processes, both the in-place upgrade from 2016 to 2019 and the storage migration, I did all of those with live VMs, so I never had to shut those down. And incur any downtime.